Good day, students. Welcome to another class of format group of school online lesson. The online lesson we put together to give you access to quality learning at your own pace. I encourage you to take a comfortable position and get ready to learn with your pen and paper. We will work for you to maximize your learning experience during the course of this course. Some questions will be asked to test your mastery of the subject. Ensure you pay rapt attention to enjoy your class. My name is Mrs Adeoye from Omat Immaculate. I'll be taking you basic science and our topic for today is radioactivity. Again, radioactivity. The objective of the lesson. At the end of the lesson, you should be able to define radioactivity. 2. You should be able to redefine radioactive elements and should also be able to give the type of radiation and explain their properties. Also, you should be able to give dangers of radioactivity and you should be able to state the importance and uses of radioactivity. My name still remains Mrs. Adeoye. Let's proceed to today's lesson. The introduction. Radioactivity is a spontaneous disintegration of atomic nuclei by emission of subatomic particles called alpha and beta, or by emission of electromagnetic rays called gamma rays. Radioactivity is the release of particles or rays by energy when certain elements break down, and the elements are called radioactive elements. Examples of radioactive elements are uranium, radium, thorium, curium, californium, phenom, rutherfordium, and americium, etc. Remember that matter is anything that has mass and occupy space, and all matters are made up of atoms. Each atom has proton and neutron and electron. Okay, good. The proton and neutron are at the center, that is neutron nucleus, while electron revolve round the atom. The atomic nuclei of some elements can decompose or disintegrate to give up some particles. Dis process is what we call radioactive, and it was first discovered by a French scientist called Anthony Henry Becquerel. He observed that in studies on the phosphorescence of substances, a mineral of uranium was able to gloss photographic plates which were kept at his side. Let me talk more on radioactivity. Everything on earth is made up of atoms, but you can see that not everything on earth is the same. Okay, good. This is because everything is made up of different types of atoms called elements. Okay, good. Atoms are really small, but each atom of an element is made up of even smaller subatomic particles. These are proton, neutron, and electron of the atom. The nuclei of some certain elements are not stable. Now, let's move to types of radioactive elements. Radioactive elements are elements that have unstable atomic nuclei and can decompose to give subatomic particles called alpha and beta, or electromagnetic rays called gamma rays. Okay, the extra energy of or radiation emitted by radioactive elements comes in three different types, which are alpha, beta, and gamma, right? Good. Natural radioactive elements. These are elements which they are unstable nuclei decomposed naturally in nature. Okay, good. Also, we have artificial radioactive elements. These are elements that are not discovered in nature but are artificially introduced in the laboratory. Do you understand? We have natural radioactive elements and we also have artificial radioactive elements. These are the two types of radioactive elements, right? And we say radioactive elements can be natural or artificial. In natural radioactive, the substance already has radioactivity in the natural state, while in artificial radioactivity, the radioactivity has been induced by irradiation. Don't forget, we say radioactivity is the release of particles or rays of energy when certain elements break down, right? There are three types of radiation, okay? Now let's go to them one after the other. We have alpha radiation. This consists of a stream of positive charged particles called alpha particles. It has atomic number of 4, a charge of +2, that's helium nucleus, right? When alpha particle is ejected from a nucleus, its mass number decreases by 4 and its atomic number decreases by 2. And you can see from this example that uranium decompose to give helium and thorium. Okay, good. Now the next one is beta radiation. It is ejected when a neutron in the nucleus is converted to proton. Therefore, the mass number of nucleus remain the same, while the atomic number increases by 1. These are negatively charged particles and travel a half speed of light and penetrate few centimeter of wood but stopped by a centimeter of aluminium plate. We can also say that beta radiation is a stream of beta particles which are negatively charged. This particle can more easily penetrate material like clothes, and they can even get deep into your skin when they can do harm to your cells, but they can be blocked with denser material like aluminium. Is that okay? We have some properties of beta particle, which are beta particles may travel several feet in air and is moderately penetrating. Okay, beta radiation can penetrate human skin to the germinal layer, you know the layers of the skin, right? Good. Where new skin cells are produced. If high level of beta emitting contaminants are allowed to remain in the skin for a prolonged period of time, they can cause skin injury. Beta emitting contaminants may be harmful if deposited internally. The third type of radiation is gamma radiation. These are not streams of particles but are high energy electromagnetic waves. They have no mass and no charge. That means they are not negative and they are not positive. And they travel at the speed of light. They are only stored by lead and thick concrete. Okay, good. Gamma radiation are able to travel many feet in air and many inches in human tissue. They readily penetrate most material and are sometimes called penetrating radiation. Okay, good. Gamma radiation and X-ray are electromagnetic radiation like visible light, radio waves, and ultraviolet light. Dis electromagnetic radiation differ only in amount of energy that have gamma, right? Gamma ray and X-ray are the most energetic of these. Dense material are needed for shielding from gamma radiation. Clothing providing little shielding from penetrating radiation. but we prevent contamination of the skin by gamma emitting radioactive material. Gamma radiation is easily detected by survey meters with a sodium iodide detector probe. Next, we move to uses of radiation. Radiation helps to ensure the high quality and safety of our daily lives. Smoke detectors to warn us of fire, X-ray machine to detect weapon or other devices in luggage and cargo, and certain types of imaging to look for disease are all application of radiation for the benefit of society. Now let's look at the uses of radiation. One, radiotherapy, e.g. cancer is treated using high energy radiation such as X-ray. Hospital uses radiation in wide range of ways: X-ray, CT and gamma radiation to produce detailed images of human body, which provide valuable diagnostic information for doctors and their patients. Radionuclides are also used directly treat illness such as radioactive iodine, which is taken up almost exclusively by the thyroid to treat cancer. Radioactive tracer and dyes are also used to be able to accurately mark a specific area or system. Number two, second uses of radioactivity is radiography. Radiation such as X-ray is used in taking pictures of internal organs and bones inside the body. Then we also have sterilization. Gamma rays are used to kill germs in medical instruments or food that cannot be heated. Then we also have carbon dating are used in determining the age of ancient objects, that is old objects. Then another uses of radioactivity is in nuclear energy generation. Great energy are released during radioactive decay in a fission chain reaction. Such energy are used in generating of electricity and highly destructive nuclear weapon. 6. Some elements are used in smoke detectors. Example, americium 241, that's the periodic number. Then we also have some radioactive elements are also used in making different material such as mantles for gas and kerosene lamps. Radioactive material are used as tracer to measure environmental processes, including the monitoring of silt, water and pollutants. They are used to measure the map effluent and pollution discharge from factories and sewage plants, and the movement of sand around the harbors, rivers and bays. Radioactive material used for such purpose have short half-life and decay to background level within days. Then in homes, most first aid kits found in our homes contain items sterilized by radiation, including cotton wool, bandage and burn dressing. Okay, so these are the uses of radioactivity. Now, dangers in radioactivity. We are exposed all the time to natural low level of radiation in the atmosphere, but exposure to high energy radiation can cause: 1. Cancer in human and other living things. 2. Skin burn, which is much more than sunburn. 3. Radiation sickness. 4. Mutation to the DNA inside the cells of the body. 5. Radioactive elements are used in making weapons for mass destruction. Radioactive rays have a lot of important uses, and they also cause some dangerous problems if they are not handled properly. Okay, The main danger from radioactivity is the damage it does to the cells in the body. Most of this damage is due to the ionization when the radiation passes all through its level of radiation are high, and there can be damage due to heating effect as your body absorbs the energy from the radiation. Rather like eating food in the microwave oven. This is particularly true of gamma rays. Radiation can also interfere with human reproduction. It can cause sterility, that's inability to produce young ones, making reproduction impossible. It can also cause mutation in developing embryos. In conclusion, radioactivity is the release of particles or rays of energy when certain elements break down. Radioactive elements could be natural or artificial. Okay, and we have types of radiation. We have alpha, beta, and gamma are the three main types of radiation. We also said that radioactive is useful in medicine for treating various diseases and sterilizing equipment. Also, we said, despite its uses and advantages, radioactivity is dangerous. It can cause burns, radioactive radiation sickness, DNA mutation, and cancer. Okay, so this is the end of our lesson. Okay, good. An assignment has been given to you. Try and do the assignment. Submit to your teachers for marking. Okay, thank you very much. I hope you enjoyed the lesson. Thank you very much. See you another time.